Is it the screen is visible to all?
Yes, sir.
Yes, sir.
In the previous lecture, we've seen that how to find the solution of semi-linear partial differential equation with satisfying the initial condition. Okay, so in this lecture, we will discuss what is the Cauchy-linear partial differential equation. Okay, how to solve, how to find the solution of Cauchy-linear partial differential equation with satisfying the initial condition. Okay, so next point is Cauchy-linear partial differential equation. Next point is Cauchy linear partial differential equation. Okay, we know that the Cauchy linear partial differential equation is given by the Cauchy linear partial differential equation. It's given by capital P into small p plus capital Q into small q is equal to R. Give it as an equation number 1. Okay, where the capital P, capital Q and capital R are the functions of x, y, z. Okay, and are continuously differentiable and are continuously differentiable. Okay, and also do not vanishes simultaneously. Okay. Okay, so this is the Cauchy linear partial differential equation is in the form of Pp plus Qq is equal to R, where Pq are the functions of x, y, z and they are continuously differentiable. Okay, if look at it, if the solution z of xy defines as a on integral surface okay, in x, y, z space, okay, 3D space. If the solution z of xy, function of xy, z is the function of xy, defines the integral surface in the xyz space. Okay, the geometry कशी असेल पहा. Suppose this is the surface. Okay, so now for this point, this is the tangent plane. Okay, so this is the vector PQR. Okay, and normal to this vector at this point is small p into small q into minus 1. Okay, that is zx, zy and minus 1. Okay, we can write the given partial differential is in the form of dot product of p q r into, okay, small p into small q into minus 1 is equal to 0. The dot product of two vectors are 0. They are nothing but the two vectors are perpendicular to each other. Look at here. Okay. Now, look at it. The normal to this surface, okay, z is the function of xy. This surface adds direction ratios. Like zx, zy into minus 1. Okay, so this vector is normal to the PQR. Okay, give it as an equation number 2, statement number 2. Okay, now equation 1 state the condition that the integral surface surface is such that at each point the line, okay, at the each point the line, sorry, at each point, okay, the line which with direction ratios, direction ratios P, Q and R, okay, is tangent to the surface at that point. Okay, thus any surface Z is the function of xy. Okay, that surface is an integral surface if and only if the tangent plane contains the characteristic direction P, Q and R, okay, which is the direction field defined by the partial differential equation at each point. Okay, look at it. This is the vector PQR and the normal vector PQ and minus 1. This vector is perpendicular to this vector. Why? Because the dot product of two vectors is 0. Okay, now look at it. What is the statement? Now equation 1 states that the condition that integral surface is such that at each point the line with direction ratios PQR, this line, this vector, okay, PQR is tangent to the surface at that point. Is tangent. हा काय तुमचा surface ला tangent. Okay, PQR is tangent to the surface at that point. Thus, any surface Z is equal to Z of xy is integral surface if and only if the tangent plane contains the characteristic direction PQR, which is the direction field defined by the partial differential equation at that point. Okay, at each point. Now, the characteristic curve are the space curves whose tangent at each point coincide with the characteristic direction PQR. Okay, at that point. Okay, so that is, what is the meaning of this one? That is the tangent to the curve is parallel. The tangent to the curve is parallel or proportional to the direction, characteristic direction at every point on the curve. curve is given by, on that curve and are given by the following ordinary differential equation. And that ordinary differential equation is given by dx upon p is equal to dy upon capital Q is equal to dz upon r, or we can write dx by dt, okay, where t is the parameter, is equal to p, okay, or dy by dt is equal to q, capital Q, is equal to dz, or dz by dt is equal to capital R, and that by existence and uniqueness of the solution of initial value problem, the ordinary differential equation possesses the characteristic curve. Okay, so by the existence and uniqueness of solution of initial value problem, of ordinary differential equation, it possesses a characteristic curve. Okay, and that curve is given by x is the function of x naught, y naught, z naught, and t. Y is the function of y of x naught, y naught, z naught, and t. Similarly, z is the function of x naught, y naught, z naught, and t. Okay, so this is the equation number star. Okay, to each point x naught, y naught, z naught. To each point x naught, y naught, z naught. Now eliminate the parameter of star, okay, that t, eliminate t, so we get the required integral surface. The required integral surface. Okay, so this is the method to solve the Cauchy-linear partial differential equation. Okay, so dx upon p, dy upon q, and dz upon r, these are the ordinary differential equation. By existence and the uniqueness of this solution, they possess the, it gives the characteristic curve. Okay, so which is in the form of x is equal to x naught, y naught, z naught, t. Y is the function of x naught, y naught, z naught, and t, and z is the function of x naught, y naught, z naught, and t. And eliminating t from these three equations, we get the required integral surface with satisfying the initial condition. Okay, so one theorem is there. Okay, next point is theorem. Okay, the theorem जरा मोठा आहे, समजायला हार्ड आहे. ओके, नीट लक्ष द्या, जेव्हा एक्झाम्पल घेऊया तेव्हा अजून व्यवस्थित समजेल. ओके, कन्सिडर the first order Cauchy-linear partial differential equation. First order Cauchy-linear partial differential equation. Q is the function of x, y, z into zx, that is small p. Okay, Q is the function of x, y, z into zy. It is capital Q, so small q. And R is the function of x, y, z, where capital P, capital Q, and capital R have continuous partial derivative. Continuous partial derivatives. Okay, with respect to x, y, and z. and they do not vanish simultaneously. Do not vanishes simultaneously. Okay, statement is मोठा आहे suppose. So let Z is equal to Z naught of S. Okay, be the prescribed along the initial curve. Prescribed along the initial curve. Okay, and the curve is denoted by this symbol. Okay, this is the representation of curve. X is equal to x naught of S, parametric equation. Y is equal to y naught of S. Okay, where x naught, y naught, and z naught be the continuously differentiable function. Where x naught, y naught, and z naught be
Sir,
continuous. Okay. Hello.
sir, after initial curve, sir, what you have written? Sir,
Then,
there only, second last line.
this is
What
the
is that
symbol of
symbol?
curve. Okay,
Okay, sir.
this is the symbol of curve. Initial curve. Okay. So where x naught, y naught, and z naught be the continuously differentiable function. Continuously differentiable function, and further that parameter running from a to b. Further, this parameter s is running from a to b. Okay, and if dy naught upon ds into p of x naught of s, y naught of s, and z naught of s minus. Okay, suppose this condition satisfies, then we have to prove that. Which condition? If dy naught of ds into p of x naught of s, y naught of s, and z naught of s. Okay, minus dx naught divided by ds upon ds into q of x naught of s, y naught of s, and z naught of s is not equal to 0. Okay, then to prove that there exists a unique solution. Unique solution, z is the function of xy. Okay, defined in some neighborhood of initial curve. Defined in some neighborhood of initial curve. Sorry. Initial curve. Okay, which one curve? This one. Initial curve. To prove that there exists a unique solution z of xy defined in some neighborhood of initial curve which satisfies the partial differential equation and the initial condition. Initial condition. What is the initial condition? Z is the function of x naught of s and y naught of s. It's equal to z naught of s. Okay, z is the function of x, y naught. So this is the initial condition at initial point. Okay, look at the theorem. This is the statement of the theorem only. Consider the first order Cauchy linear partial differential equation pp plus qq plus r is equal to r, where p, q, r are the continuous partial derivative with respect to x, y, z, and they do not vanish simultaneously. And z is equal to z naught of s with the prescribed along the initial curve. Okay, x is equal to x naught of s and y is equal to y naught of s, where x naught, y naught, z naught be the continuously differentiable function, where this s is running from a to b. And if dy naught of ds into p of x naught of s, y naught of s, and z naught of s minus dx naught upon ds into q of x naught of s into y naught of s and z naught of s is not equal to 0. If this condition satisfies all conditions, then to prove that there exists a unique solution z of xy defined in some neighborhood of initial curve, okay, which satisfies the partial differential equation and initial condition. Okay, which one? Z is equal to x naught of s and y naught of s is equal to z naught of s. Okay, पहा पुन्हा एकदा वाचा जरा ते. Okay, now look at the proof now. Let the Cauchy linear partial differential equation. Let the Cauchy linear partial differential equation is given by p of x y z into zx plus q of x y z into zy is equal to r of x y z. Okay, give it as an equation number 1, where capital P, capital Q, and capital R are having, these all things are given to us, okay, are having continuous partial derivatives and do not vanish simultaneously. Okay, and let the initial condition x is equal to x naught of s, y is equal to y naught of s, and z is equal to z naught of s be the initial curve. Initial curve, and it satisfies this one. Z is the function of x naught of s and y naught of s. It's given by z naught of s. Okay, give it as an equation number 2. Okay, and this condition is called as admissibility condition. Which condition? This one. dy naught upon ds into p of into p. Okay, minus dx naught upon ds into q is not equal to 0. Okay, this condition is called as admissibility condition. This is called admissibility condition. Okay, now we have to prove that it's claimed. We have to prove that the z of xy, okay, z of xy is the unique solution, of equation 1 satisfying initial condition. Initial condition. Okay, which one? Z of x naught of s and y naught of s is equal to z naught of s. Okay, now we know that the integral surface of equation 1 is the family of space of curve. Okay, surface म्हणजे असतो कधी काय तो family of curves असतो. Okay, and is given by the system of ordinary differential equation. Okay, okay. We know that the integral surface of equation 1, that is the given partial differential equation, is the family of curves. Okay, we know that the integral surface of equation 1 is the family of curves and it's given by system of ordinary differential equation. System of ordinary differential equation. Which one? Dx by dt. Okay, it's equal to p of x, y, z, and dy by dt is equal to p of x, y, z, and is equal to and dz by dt is equal to r of x, y, z. Okay, give it as an equation number third. Okay, now we have to solve this equation to find the unique family of characteristic curves passing through the point x0, y0, and z0. Okay, we solve these equations to find the unique family of characteristic curves passing through the point x0, y0, and z0. Okay, and that gives x is the function of x0, y0, z0, and t. Okay, or we can write in arbitrary form, x is the function of s and t. Y is the function of x0, y0, z0, and t, which is equal to y is the function of st. Okay, in arbitrary form, in parametric form, and z is the function of x0, y0, z0, and t, which is equal to z of st. Okay, give is equation number 4, where x, y, z have continuous partial derivatives. Continuous partial derivative with respect to s and t. Okay, and it satisfies the initial condition. Initial condition. What is the initial condition? X is the function of s0 is equal to x0 of s. Y of s0 is equal to y0 of s. And z of s0 is equal to z0 of s. Okay. Now, from the admissibility condition, we observe that admissibility condition. Okay, we have dou of xy with respect to Jacobian of xy with respect to st at point t is equal to 0 is equal to what we have then? Jacobian dou x by dou s, dou x by dou t, this is dou y by dou s, and dou y by dou t. Okay, that is equal to x yes, x t, y yes, and this is y t. After solving this, we get x yes into y t after solving this, x yes into yt minus xt minus ys. Okay, at t is equal to 0. What is the yt? Dy by dt is nothing but q. Okay, look at it. Dy by dt is nothing but q, and dx by dt is nothing but p. Okay, so ds xs into q minus ys into capital P at t is equal to 0. Okay, is not equal to 0. Why? On curve, given curve. Since from 2. Okay, admissibility condition, this one. Okay, this is called admissibility condition. It is given to us. dy naught upon yes into p minus ds naught x naught upon ds is not equal to 0. Okay, that implies is not equal to 0 on that curve. That implies x and y involves yes and t explicitly. Okay, what is the meaning of this one? X and y मध्ये काय तुमच्या yes and t present आहे. Okay, so hence solving the first two equation of 4 to equation of 4 for s and t. Okay, we obtain the relation phi of x1. Okay, from this equation, x and y, x of st and y of st. By solving these two conditions, we get the relation between x and y, that is phi of xy. Okay, we obtain the relation say phi of xy, okay, which is equal to z of s is the function of xy and t is the function of xy. After solving the two equation of equation number 4, give it as an equation number 5. Okay, now step number 1, we have to prove that the phi of xy is the solution of 1. This is the solution of 1. Okay, the given partial differential equation. Step number 1, to prove that phi of xy is a solution of equation 1. Okay, that is to prove that phi of xy satisfies equation 1. Okay, a solution आहे equation तुम्ही काय करायला पाहिजे, तो satisfy करायला पाहिजे. Now what is the left hand side? p into phi x plus q into phi y. Okay, zx म्हणजे इथे काय आहे तुमचा, z म्हणजे काय phi of xy, small p and this is small q. This is the left hand side, which is equal to p into differentiate phi with respect to x, this one. Okay, differentiate phi with respect to x. So here we get first z is the function of s and s is the function of x plus z is the function of t, then t is the function of x. Okay, plus q into differentiate this one phi of xy with respect to y now. Z is the function of s and s is the function of y. Look at here. Plus z is the function of t, then t is the function of y. Okay, now taking z as common from these two, which is equal to z yes into p into yes x plus q into yes y plus now zt taking common from these two, zt into p into tx plus q into ty. Okay, which is equal to zs into What is the meaning of p? Dx by dt, that is xt. Look at it. What is the value of p? Dx by dt, that is xt. Okay. Xt into sx plus, what is the q? Yt into sy plus zt into p is xt into tx plus, what is q? Yt into ty. Okay, so that is equal to, said yes in the bracket. Now write down this first one, sx into xt plus sy into yt plus zt into bracket tx into xt plus ty into differential with respect to yt. Okay. Now, however, by the chain rule, now look at this one. Okay, तुमचा dx by dt upon ds by dt into dx by, sorry, the high equation. What is the sx? ds by dx into dx by dt. Okay, by using chain rule, what we have, what is the value of this one is ds by dt. Okay, that is equal to said yes into bracket. But what is the value of yes? Derivative of yes with respect to t is 0. Okay, similarly here, ds by dy into dy by dt, our term. Okay, from this we get, by using chain rule, ds by dt. The derivative of yes with respect to t is 0. So here we get all this value is 0 plus 0, 0. Okay, plus zt. Now look at here. Tx into xt. Tx into xt. Now what is the meaning of this? The derivative of t with respect to x into dx with respect to dt. Okay, by using chain rule we get dt by dt. Derivative of t with respect to t is 1. Okay, haki deil 1. Okay. Wait a minute. Okay, so this is the one. Like this. Wait a minute. So this is ZS into 0 plus पूर्ण ह्याची पूर्ण व्हॅल्यू किती ती 1 येते. Okay, so this is using chain rule. Value of this one is whole is 1. Okay, dx into xt plus dy into yt is equal to 1. Value of this is 1 by using chain rule. Okay. Tx ना यहाँ का tx into xt plus ty into yt dx upon xt plus 1, it is 2 right. 2 यायला पाहिजे नाही 1 plus 1.
Yes, sir.
2 यायला पाहिजे ना, तेच म्हणते याचा एक आन्सर 1 याचा एक आन्सर. Okay, next lecture ला पाहून सांगतोय मी. हे काय येणार dt by dx into dx by dt. By using chain rule we get here value of this one is 1. Similarly for this one is 1. 1 plus 1 2 यायला पाहिजे. zt of 2. If you left hand side हा ना 0 plus what is the zt? मी डायरेक्ट घेतला इथे टेक्स्ट बुक. zt is equal to from this equation dz by dt. dz by dt is nothing but r of x, y, z. ओके, हा वन कसा आलाय मी नंतर सांगेन. Okay, so this is ZT. Okay, so what is the left hand side? Left hand side is P into phi x plus Q into phi y is equal to ZT, but ZT is what? R. Okay, therefore phi of xy satisfies the partial differential equation. Okay, फक्त ही कंडिशन कशी 1 + 1 2 यायला पाहिजे, ते कसं 1 आला मी सांगेन नेक्स्ट स्टेप. Okay, now step number 2, to prove that the phi of xy satisfies the also initial condition. Okay, step 2, to prove that phi of xy satisfies the initial condition. Okay, that is, what is the initial condition? Z is the function of x naught of s and y naught of s. Okay, is equal to z naught of s. Okay, therefore, now the solution phi of xy is given by, what is the value of phi of xy? Is equal to z of s is the function of xy and t is the function of xy. Okay, so this is the phi of xy. Now obtain the initial condition. To obtain the initial condition, this condition, put t is equal to 0. To obtain the initial condition, put t is equal to 0. Okay, so what we get then? Phi of x naught and y naught is equal to z is the function of s of x naught y naught into t is 0. So this is 0. Okay, so that is equal to z is the function of s and 0. Okay, which is equal to z naught of s. Okay, so phi of x naught and y naught is equal to z naught of s. Therefore, phi of xy satisfies the initial condition. Okay, initial condition. And in step number 3, we have to prove that the phi of xy is unique. Okay, look at it. Step number 3, to prove that phi of xy is unique. Okay, now suppose the solution is not unique. Solution is not unique. Okay, therefore, that implies there are two curves that each point of initial curve. Okay, suppose the solution is not unique. Okay, what is the meaning of solution is not unique? There are two curves that to each point of the initial curve. Wait a minute. Sorry, this sequence. Suppose the solution is not unique. What it implies? There are two integral surfaces. There are two integral surface which intersects along the given initial curve. that each point of initial curve there is one and only one characteristic curve. Okay, look at here. There are two integral surface which intersects along the given initial curve. ओके, जर दोन सरफेस एकमेकांना इंटरसेक्ट झाले तर काय तयार होईल, तिथे कर्व तयार होईल आणि तो कर्व कुठे असेल, intersects along the two initial curve and that to each point of the initial curve there are one and only one characteristic curve. Okay, तिथे काय असेल, only one characteristic curve असेल. So therefore this characteristic curve has to lie on the both the surface. आणि तो characteristic curve काय असायला पाहिजे, त्या दोन्ही surface वर असायला पाहिजे. Okay, hence the same family of characteristic curve which passes through the each point of the curve lie on the both the surface. Hence the both the surface must be whole set as a both. म्हणजे दोन नसून हे एकच असते. Okay, therefore this characteristic curve has to lie on both the surface. Both the surface. Hence, same family of characteristic curve which passes through each point of curve lie on both the surface. Hence, both the surfaces must whole set as both, okay, and are generalized by same family of characteristic curve. Thus phi of xy is unique. Okay, काय म्हणतो हा स्टेटमेंट? This characteristic curve, okay, there are two integral surface which intersect along the given initial curve. जर दोन सरफेस एकमेकांना इंटरसेक्ट झाले तर काय होतील, कॅरेक्टरिस्टिक कर्व मिळेल आपल्याला, इनिशियल कर्व असेल. and to each point of initial curve there are only one and one characteristic curve. Okay, therefore this characteristic curve has to lie on the both the surface. Okay, तो characteristic curve कसा असायला पाहिजे, दोन्ही surface वर असायला पाहिजे. Hence same family of the characteristic curve which passes through the each point of the curve lie on the both the surface. Hence the both the surface must be the whole set. म्हणजे ते दोन assume केलेले होते ते दोन असून कसे असतील, एकच असतील. Why? Because तो काय होईल, hence the same family of characteristic curve which passes through the each point. Okay, hence both the surfaces must be the whole set as both. Okay, then phi of xy is unique. Okay, theorem थोडा समजायला अवघड आहे. Okay, सारखं वाचल्यानंतरच कळेल. Okay, हा theorem सुद्धा मी पहिल्यांदा शिकवतो. theoremचं स्टेटमेंट इतका मोठा आहे की एकदा एक्झाम्पल सॉल्व्ह केल्याशिवाय हे समजणार नाही प्रोसेस. Okay, so this is the theorem. Consider the first order Cauchy linear partial differential equation. P into small p, q into small q is equal to r, where p, q, r are the continuous partial derivatives with respect to x, y, z. They do not vanish simultaneously. Okay, and let z is equal to z naught of s be the prescribed along the initial curve. This is the symbol of curve. Okay, x is equal to x naught and y is equal to y naught of s, where x naught, y naught, z naught are the continuously differentiable function. With this admissibility admissibility condition holds, then there exists a unique solution z of xy, that is phi of xy, defined on the neighborhood of that initial curve, which satisfies the partial differential equation and initial condition. This one. Okay. याचे एक्झाम्पल आपण मंडेच्या लेक्चरला सॉल्व्ह करूया. ओके, एक्झाम्पल एकदा सॉल्व्ह केले की व्यवस्थित समजेल. Okay, solve the initial value problem for the cosine linear partial differential equation. Z into Zx plus y is equal to 1, Zy is equal to 1. Okay, after solving this example, तुम्हाला काय होईल व्यवस्थित समजेल. Okay, for today it's sufficient now. Wait a minute.